In past episodes, I've talked about how AI models learn by looking at lots of real-world training data and then nudging their many internal parameters or weights to come to capture and remember the statistical patterns that relate inputs to outputs. We talked about how generative AI is essentially a random walk through those patterns so that the model creates novel but sensible outputs. And we talked about specifically how those language models generate the next word in a sentence by using the sentence so far and the input prompt. Now, another kind of generative AI that's getting a lot of use these days is image generation. Models like DALL-E, Stable Diffusion, all kinds of fun consumer apps, bunch of others, all work by taking an input prompt of some kind, often a description of a particular set of things and characteristics, and then they can create astounding images that fit that prompt in ways that look totally natural, not just different images sort of glued together. So how do these image models do that? How do they take this input and take pieces of an image and make them fit together so well and apply broad stylistic characteristics to the whole thing? Today, I'll try to give you, as usual, a very high-level description, again, to try to leave you with some intuition about how it works. Now, the most popular approach to image generation right now is called the diffusion model. And the way it works is that it takes in a lot of labeled images as training data. For example, it might look at a picture of a gray cat, which has a text label, gray cat, associated with it. The model then takes that image and slowly adds noise to it, which means it randomly flips random pixels in the image to some other colors. As it does this, you can imagine the image sort of progressively fades from view and eventually just looks like noise, like static, just a random jumble of pixels with no discernible image in it at all. Now the model remembers the path it took from the good image to the pure noise image and all the pixels that got flipped to get there. And then it reverses that path. Now the reverse path, of course, takes a starting image of pure noise and progressively applies changes to the individual pixels such that a gray cat progressively appears out of that noise. Then the model, the AI part, learns from that reversed path. And so it does, as usual, it just does this over and over again with lots of different images to learn sophisticated statistical patterns of how to turn noise into a very large variety of images relating to the specific text descriptions associated with them. Then, once the model has been trained, it is used by taking in a new input prompt, say, cat on the moon in the style of Matisse. Now the model starts with random noise image again, and it uses all its internal parameters that have been trained to nudge the pixels of that noisy image into directions that are consistent with the input prompt. The result is that multiple images and styles can be effectively blended in a novel way by these nudged pixels, and the resultant image will appear out of the noise, and it will look consistent, not like a patchwork of different images. Now, in episode 3 of this series, when I talked about generative AI, I mentioned that generative language models can be used for image generation. Well, how does that work, given what I just described? Again, at a super crazy simplistic level, just trying to give some intuition here. The language models are very good at pulling out the semantic content of the image and its associated text, meaning it creates a kind of representation of the meaning of contained in the text and the image. And those models are great at figuring out the context, meaning what parts require your attention to really understand it, what matters in them. And then those learnings are used to guide the diffusion model to put focus on the elements of the image that are more relevant to what is being asked. Hopefully that all makes sense. Thanks, everyone. That's my thought for now. I'll be back again soon with more. Take care.